We're going to start with this warm-up. In order to raise money, you're planning to work during the summer babysitting and cleaning houses. You earn $10 per hour while babysitting and $20 per hour while cleaning houses. And you need to earn at least, notice folded, $1,000 during the summer. So X is going to represent babysitting, while Y represents cleaning houses. We're going to create the inequality that goes with this. So 10X plus 20Y is going to be greater than or equal to 1,000. Think about this like you're going on a trip and you need to have $1,000 to be able to go. If you don't have $1,000, then you're not able to. So the lowest amount possible to get would be $1,000. You want to take that information and graph it here on the graph provided. I get the whole graph on the screen. Now it's very important that you label your axis. So my x-axis represents babysitting, while my y-axis represents house cleaning. It is very important that you label what your axes are and also your scale of your graph. So I'm going to choose to go up by 5 for my y values. And I'm going to go up by 1s for my x values. Now if we look at our equation, 10x plus 20y greater than or equal to 1,000, this is not in a situation where we can graph easily. So I need to put this in y equals mx plus b. I say equals mx plus b because it's just easiest. I'm going to start by subtracting 10x from each side. You get 20y is greater than negative 10x plus 1,000. The reason I put the negative 10x first is because I want it to look like slope-intercept form. Now I'm going to divide each part by 20. Remember, I don't have to flip my sign if what I'm dividing by is positive. I'm also going to leave this as a fraction, so negative 1/2 x. You can change it to a decimal, but because we're talking about slope, rise over run is easier as a fraction, so I can say I go down 1 to the right 2. And I'm going to have plus 50. So my y-intercept here will be 50. I'll go down 1 to the right 2, so that'll be 249. Down 1 to the right 2, so 448. 647. 846. And then 1045. Now, the questions below are going to say, do we want to connect our points? And yes, we do, because right now I'm only working every even number of babysitting hours. I can work 1 hour or 7 hours. So we do want to represent that by connecting our points. So that means it is a continuous graph because we connect our points. Again, because we can work all hours. Should we draw arrows at the end of our graph? Let's think about this. Should we extend our line into every quadrant? Well, is it possible to work a negative hour? And the answer is no, we can't have negative time. So no, we do not want our arrows. And the reason being because time cannot be negative. And if I were to extend my graph right on the y-axis, the very next thing I would have to graph here would be a negative x value, and that is not okay. So to list 3 ordered pairs that represent exactly $1,000, that's going to be any point that was on that line I just graphed. So the easiest one would be to work 0 hours babysitting and 50 hours cleaning houses. And then, as I said, we could work 2 hours babysitting, 49 hours cleaning house, 4 hours babysitting, 48 hours cleaning, 6, and I know we're past 3 here, but 6:47, 8:46, or 10:45. And we can keep going past there. You don't have to just use those. But ultimately, remember what we're doing is taking the equation, 10x plus 20y being greater than or equal to 1,000, and we're trying to pick values that will make that equal exactly $1,000. So the question says, is it acceptable to earn more than $1,000? Yes, it is acceptable because remember I want to earn at least 1,000. So because of the word at least, it makes it acceptable. So three order pairs that represent earning more than 1,000. So anything that was above the line that I grabbed, I could pick 10 and 50. I could pick 25 and 40. Let's say 7 and 61. Again, I'm going to look back at my equation. 10x plus 20y is greater than or equal to 1,000. And as long as when I plug in 10 for x and 50 for y, that equals more than 1,000, that is acceptable in our graph. So number 6 says, is it acceptable to work 10 hours babysitting and 10 hours cleaning houses? And where will this fall in relation to our graph? Well, I can plug in 10 for my x value. Remember, I get paid $20 an hour babysitting, so 10 hours there. And we want to know, is that greater than or equal to 1,000? I get 100 plus 200. We want to know, is that true? It is greater than or equal to 1,000. This is false. That does not happen. So no, it is not acceptable. And it falls below the line on the graph. And then say, how would the inequality change and how would the graph change if you needed to earn more than $1,000? Well, my equation would turn from 10x plus 20y, instead of greater than or equal to be greater than 1,000. And my line would change to dotted, because that line would no longer be a part of my solution. It's the only difference when we're graphing inequalities versus equations. When we have an equation, you have an equals to, which means all my answers have to be on this blue line. Any solution that is not on the line will not satisfy the equation. Same thing happens with inequalities. The difference is with an equation, we only have one answer that satisfies every x value. In an inequality, we have a set of answers that satisfy every x value. So if I have y is less than or equal to x plus 3, my solutions will be everywhere on this blue line, but I also have to use anything that would also work. So I shade below. Now I like to use a method called the test method, and I pick the point 0, 0 if I can. So I plug that in. Is 0 less than or equal to 0 plus 3? So in this situation, it is true. 0 is less than or equal to 3. And if that point is true, then you shade the area of where 0, 0 is. For the next equation, I'm going to test 0, 0 again. So is it true that 0 is greater than or equal to 0 plus 3? So 0 is greater than or equal to 3. That is not a true statement, so I'm going to shade the part of the graph that is on the opposite side of 0, 0. Now, the only difference is when we have a greater than or less than is when it is just greater or less than. All my lines are going to be dashed because that line is no longer a part of the solution. It's just things either greater or less than. And then you can use the test method again and plug in. So, is it true that 0 is greater than 0 plus 3? And that is not a true statement that 0 is greater than 3, so I shade above my dotted line. The other one, if I'm going to test 0, 0, is it true that 0 is greater than, 0 is less than 3? And that is a true statement. Therefore, I shade the part where 0, 0 is. Now, when graphing inequalities, first step is to always graph that boundary line. So start at your y-intercept, put a point, and then go from your slope, whether it's up or down, positive or negative. And then if you have an equals to, okay, so if you have the greater than, equals to, less than, equals to, then you know that it'll be a solid line, where if you have a greater than or less than, then it's just going to be the dashed line. The next part is to determine your shade. So we talked about it before. If it's greater than or greater than or equal to, you shade above. If it's less than or equal to, you shade below. Let's practice here on our own. We want to start our graph on our y-intercept. So here it is 1. So then we just follow our slope. We go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. When we run out of space, we can go back to our y-intercept and go down 2 to the left 1. And once we get our points plotted, then we have to decide, is it a dotted line or a solid line? In this case, notice it's just less than, so it's going to be a dotted line. And then because less than, we shade below. We want to use the test method. Is it true that 0 is less than 1? Yes, it is, so I shade the side with 0. Okay. Start at my y-intercept for number 2, which is positive 2. I have a slope of negative 3x, so I go down 3 to the right 1. Or I can go up 3 to the left 1. And then I notice I have a greater than or equal to, so because it's equal to, I have a solid line. Greater than means on top of the line. If you're having trouble determining what's the top or the bottom, again, you can plug in to test your method. Is it true that 0 is greater than or equal to 2? And no, that is not the truth, so I need to shade on the other side of the line. For y is greater than 4, you go up to y equals 4. Remember, this is a horizontal line, just greater than, so it's a dotted line. And is it true that 0 is greater than 4? No, it's not, so I shade on top. For the next equation, we have x is less than or equal to 2. So I come out to x equals 2. Because it is less than or equal to, it's going to be a solid line. And this is a vertical. Then we ask ourselves, is it true that 0 is less than or equal to 2? Yes, it is. So we shade the side with 0. The last two, notice I must put in slope-intercept form. I'm going to subtract 3x from each side, which leaves me with 2y is greater than negative 3x plus 6. Divide everything by 2. So y is greater than negative 3 halves x plus 3. Start at my y-intercept of 3. Go down 3 to the right 2. Down 3 to the right 2. Or I can go back to my y-intercept and go up 3 to the right, to the left 2. Notice it is just greater than, so I'm going to make a dotted line. And because it is greater than, it needs to be on top of the line. And you can use the check method if you needed to. Finally, we subtract 4x from each side. We're left with negative 3y is greater than or equal to negative 4x plus 12. Divide everything by negative 3. Because we're dividing by negative 3, I must flip my sign. So it becomes y is less than or equal to 4/3 x minus 4. Put my y-intercept to negative 4, go up 4 to the right 3. Or I can come back to my y-intercept and go down 4 to the left 3. Because it is less than or equal to, it is a solid line. And because it's less than,